How's it going, guys? Um, so we are going to today get into the 10.7 lesson, which is essentially the end of the chapter. Okay. We're only going to do the first part of the lesson because there's kind of a lot of information. All right. So part one of the lesson is going to be adding and subtracting numbers that are in scientific notation. All right. So yesterday you kind of did a review on like remembering how numbers need to be written correctly in scientific notation, where that first number, that factor, is greater than or equal to 1 and also less than 10. All right, so obviously this rule is still going to be apply today and be really important. All right, but first thing I want us to do is just make sure we have a notebook, a pencil, and you'll probably need a calculator when you get to your activity. All right. But I am including my webcam too because there's a couple extra examples I want to go through and show you on the whiteboard here too. All right. So again, get your notebooks ready to go, pencil, and I want us to write a couple things down to start. All right. First thing I want you guys to write down is the learning target. Your learning target is I can add and subtract numbers that are written in scientific notation. All right. So remember, pause if needed, write that down, but I'm just going to keep kind of cruising here. So here we go. Let's take a look at what this says right at the top of the lesson. The first thing it says, this is, by the way, on page 450 in your textbook. All right. The first thing that this says, it's really important. All right. In order to add or subtract numbers that are written in scientific notation with the same power of 10, we have to add or subtract the factors. All right. Quick example. Right in the middle of my highlighted area here, 4.6, and then right here, 8.72, those are the factors. All right. So that's some vocab you need to know. 4.6 and 8.72, for example, those are the factors. Okay. So the really, really important thing here, let's read this second sentence. Really important. When the numbers have different powers of 10, we first have to rewrite the numbers so they have the same power of 10. All right. So I'm going to put it in perspective for you real quick. This is the same concept as having like a common denominator when we're adding or subtracting fractions. Okay. Here's the deal. We can't put these things together, these expressions together. We cannot add or subtract numbers in scientific notation until they have the same fact or the same powers of 10. Okay. Until they have the same powers of 10. So I'm going to show you what I mean by that. If we look at this first example, like if I'm looking here, if I look here, the first thing I'm going to look for is, do they have the same powers of 10? And in example A, they do. All right. So I'm going to show you this one real quick, and then we'll get into the next one, because what you should be noticing is they don't have the same powers of 10. All right. So something's different. We have to change those numbers up. We have to manipulate the numbers in some way to get the powers of 10 to be the same. Okay. That's the hardest part of the lesson. So I'm going to give you a couple of sentences I want you to write down in a minute of what do we need to do to kind of do that, to change these numbers, manipulate these numbers. All right. Let's start with an easier example though. Okay. So problem A, I'm looking, I see again, I have a power of 3 and a power of 3 for my tens. Okay. Since they're the same, I'm legitimately going to take my factors, my first numbers, and I'm just going to add them. Okay. Because our problem is addition in the middle here. All right. So here's what they do. They kind of show it in a way where they move the numbers around, and they're just showing you that you're only adding the factors that are in the front. All right. So what we get when we add 4.6 plus 8.72, we get 13.32. Okay. Now again, similar to common denominators in fractions, we don't change that exponent. All right. It does not become 10 to the sixth power. That's a really common mistake that we don't want to make. All right. That exponent does not change. Okay. It's just like a common denominator. Now, there's a problem here. There's a problem here. This number, our factor, our new factor, is greater than 10. All right. So what we got to do is we got to move that decimal. So here's what I want you to write down right now, because it's going to be helpful for you for the rest of the lesson. Here's what I want you to write down. When we move our decimal to the left, we add to the exponent. Okay, that's one thing I want you to write down. The second thing, when we move our decimal to the right, we subtract from the exponent. Okay, you're going to see why that's important right now. So back here, I'm going to show you this quick. I ended up with 13.32 times 10 to the third power. And again, my problem here is this number is greater than 10. Okay, so how do I get or manipulate this number so that it's not greater than 10? I'm going to move my decimal 1 unit to the left. Okay, so I'm going to bring down my new answer. It's going to be 1.332. So a number that's greater than 1 but less than 10. That's good. But now, guys, we have to change our exponent. Okay, so since I moved my decimal 1 unit to the left, I'm going to add 1 unit to my original exponent of 3 so that my new exponent is 4. Okay, we need to know that rule even for the next problem too. Okay, so again, when we move our decimal left, we add to the exponent. When we move it right, we subtract from the exponent. Okay, so back to my screen here. Let's take a look at this. They're just showing us that they moved their decimal 1 unit, and they're basically showing that we're going to add 1 to this 3. Okay, and this is going to be our final answer right here. All right, so the gist of it is this. In the end, we have to make sure our number is written correctly. Okay, so we added, that was great, but we have to make sure our number is written correctly, and we're going to have to manipulate it sometimes so that it is. All right, now problem B, more difficult. Here's why. The powers of 10 aren't the same. Okay, so I can't subtract right away. I can't just do 3.5 minus 6.6. I can't do it. I need to change one of these numbers. All right, I have to change one of these numbers to get it to have the same powers of 10. All right, so I'm going to make a choice. And I'm just going to follow what the book does here. They're saying that we want to rewrite 6.6 times 10 to the negative third so that it has the same power of 10 as 3.5 times 10 to the negative second. So here's the deal. I need to change this number by moving my decimal for my factor so that I can make my exponent negative 2. Okay? So how am I going to get negative 3, my exponent currently, to become negative 2? This is my thought process. Okay? How am I going to get that? I'm going to get that by adding 1. Okay? In order to add, I need to move my decimal left according to our rules from before. Okay? So what I'm going to do is, I'm going to skip this. I'm going to rewrite my number as 0.66. Okay, I moved my decimal 1 unit to the left in order to add 1 to my exponent and make it negative 2. Okay, now that I have my numbers with the same powers of 10, I can now just subtract the factors. All right, remember the factors are 3.5 and 0.66. So I'm going to subtract those. That's going to give me 2.84 times 10 to the negative second. Now this problem is different, right? Because in the end, I end up with a number that's greater than 1 and less than 10. So my answer is already in scientific notation this time, okay? I didn't have to change it around at all at the end, all right? I had to change it at the beginning to get these powers to be the same. But at the end, I end up with a number that's greater than or equal to 1 and less than 10 as my factor. And then I have my exponent here for my 10. So I'm done there, okay? All right, let me show you now on our whiteboard back here our extra example. Okay, so let's start with problem A. Let's start with problem A. Problem A says that we are adding, get you closer. We're adding 2.1 times 10 to the negative fourth. I'm adding that to 9.74 times 10 to the negative fourth. Okay? So, first thing I'm looking at, guys, is the fact that my exponent for my 10 in both expressions is already the same. Okay, it's already -4. That's good because it makes the problem a lot easier. I am simply going to take 2.1 and add 9.74. All right, so I'm going to grab my calculator here. I'm going to add those. 2.1 plus 9.74. And that gives me 11. Put these together. That gives me 11.84. Okay? So that's only part of our answer. Remember, I don't change my exponent. All right? It's like a common denominator, stays the same. I have a problem. This number, our factor, is greater than 10. Okay? So hopefully you know what I'm going to do right now. I'm going to take my decimal and I'm going to move it 1 unit to the left to put it in the correct form. Okay? Now, because I moved left 1 unit, I'm going to add 1 to -4. -4 plus 1 is -3. Okay? Here's my answer written correctly in scientific notation. All right? Hopefully we can see that well. Okay, so that's problem A. All right, which I think is a little easier just based upon the fact that we already had the same exponents for our 10s. All right, problem B is a little different. Okay, problem B says 4.7 times 10 to the 5th. I'm subtracting 7.2 times 10 to the 3rd. Okay, so I'm just going to show you on my whiteboard here. Problem. I have a 5 for an exponent and I have a 3 for an exponent. I can't subtract until they're the same. Okay, so I'm going to make a choice here. I'm going to change one of the numbers. Okay, so I'm going to make a choice. Do I want 10 to the 5th to become 10 to the 3rd? Or do I want 10 to the 3rd to become 10 to the 5th? So which number am I changing is really my question. Now, just so you're aware, it doesn't matter. It's up to you. Okay, you just got to make a choice. So I'm going to take 10 to the 5th and I'm going to make it into 10 to the 3rd by moving my decimal in 4.7 2 units to the right, because that would allow me to subtract 2 from 5. Okay, so I'm going to move this decimal 2 units, and remember, when I have an extra space, I fill it in with a 0. So my new number is this, 470. Now I can write it as 10 to the 3rd. Okay, minus 7.2 times 10 to the 3rd. All right, so I've manipulated my numbers so that my powers of 10 are the same. Now I'm simply going to take 470 and subtract 7.2. Okay? So in my calculator here, 470 minus 7.2. That gives me a pretty high number of 462.8. And remember, my power was 3. Okay, so times 10 to the 3rd power. Now this one's even extra hard because in the end, I'm left with a number that's way greater than 10. I got to move my decimal now back. I got to move my decimal back to the left 2 units. Remember, when I move left, I add to my exponent. Since I moved 2 units, I add 2 to 3 to get 10 to the 5th, and this is my final answer here. Okay, so hopefully that makes sense to you. Let me back. Hopefully that makes sense to you. Remember, guys, you can always pause and rewatch something. Okay, what I want us to do at this time is, let's see if these are good examples. Yeah, you know what? Let's see this. Let's cross multiplication. So what I want you guys to do is try these two on your own questions here. Okay, so why don't we do this? Why don't we give these a shot? So pause your video at this time, and when you come back, the answers will be up. Okay. All right, so here are our answers written correctly in scientific notation. Again, hopefully this makes sense. If not, as always, I will be in discussion. I'll be in a discussion thread on Canvas tomorrow. It's currently Monday. Tomorrow, Tuesday, I will be in there live. So if you have questions, ask me in there, or you can shoot me an email. But hopefully this makes sense. And if not, just kind of try and rewatch the video. If not, okay. So at this time, what you guys are going to do is you're going to actually go into your big ideas, and I'm going to create an assignment in here. Okay. That assignment will be a couple of problems that just works on these skills from today. All right. So good luck on your assignment, and I will talk to you guys tomorrow.